Welcome to Notes 10.8 Part 2. So again, we always start off with our y-intercept. In this case, it's 0, negative 1. Our slope in this case can be negative 1 over positive 5 or 1 over negative 5. So that means move down negative 1 and right positive 5, or up positive 1 and left negative 5. So again, we start at the y-intercept. So 0, negative 1 is right here. From there, I can move down 1, negative 1, and right 5. So down negative 1, right 1, 2, 3, 4, 5. Or I can move up positive 1, which lands me on the x-axis, and move left 1, 2, 3, 4, 5. Remember, the axis does count as a point, or as a line. So draw your nice straight line, a negative sloping line at a y-intercept of negative 1. Our y-intercept in number 6, 0, 3. Our slope can be negative 3 over positive 1 or 3 over negative 1. It's a negative slope, so that means only one of the numbers has to be negative. I start at 0, 3, which is right up here. I can move up 3, 1, 2, 3, and left 1. Oops, sorry. I can move down negative 3, right positive 1, or up positive 3 and left negative 1. So I started by doing up and left negative 1, so now I'll do down and right. So down 3, right negative 1, down 1, 2, 3, right negative 1, down 1, 2, 3, right negative 1. Sorry, right positive 1, not negative 1. So I have a negative sloping line. As I read it left to right, it goes down at a positive y-intercept at 3. Right? Equation number 7 should look very familiar. Again, when there is no x attached to the constant there. So there's no coefficient or no x. We know that we have a 0 sloping graph, 0 over 1 or 0 over negative 1. X is your indicator that, hey, I'm a slope. This number all by itself says, hey, I'm a y-intercept, 0, negative 5. So I start at negative 5, and then I move up or down 0 and right 1. Up or down 0, right 1. Right 1, right 1, right 1, right 1. Same thing, up or down 0, left 1. Up or down 0, left 1, left 1, left 1, left 1, left 1. I'll have a nice horizontal 0 sloping line. That makes sense to this graph. This is saying at every single point on this graph, y is negative 5. Well, 0, negative 5, 1, negative 5, 2, negative 5, 3, negative 5, 4, negative 5, 5, negative 5, negative 1, negative 5, negative 2, negative 5. Hopefully you get the point. So again, up 0, right 1, or down 0, left negative 1. Guaranteed that a problem like this will be on your final. And then finally, the very, very, very special case scenario is when we have x equals a number. In every other equation, we've always had y equals a number. So when we have x equals a number, this is saying that every point on this graph, x will be negative 3. So take a look. Here's negative 3 for an x value, right? If at every single point x will be negative 3, what does that mean? We'll never hit the y-axis. So there is no y-intercept. The slope of every point being negative 3 is a vertical line, is undefined. So this is just a special case. Whenever you have x equals a number, you're going to get a vertical, undefined graph. All right, so that means we have something like 1 over 0, or negative 1 over 0. So what does this mean? It means move up 1, right or left 0, or down negative 1 and right or left 0. So let's do that. So we're starting at, where do we start? In this case, we just start where x is negative 3. So right here. This is the one time you don't start on the y-axis. And you move up 1, right or left 0, up 1, right or left 0, up 1, right or left 0, up 1, right or left 0. And hopefully you can see we're forming this vertical line. Down 1, right or left 0, down 1, right or left 0. And we get this very straight vertical line, which is undefined, and at every single point x is negative 3. We have negative 3, 0, negative 3, 1, negative 3, 2, negative 3, 3, negative 3, 4, negative 3, negative 1, negative 3, negative 2. So that's why it's x equals negative 3. It's the end of part 2.